everyone. Welcome to another episode of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. My guest this week is HanBin Lee, CEO of Seoul Robotics. HanBin and I chat about their 3D perception software with deep learning, including the motivation behind its development and how this software is different from other 3D computer vision software solutions on the market today. But before we bring in HanBin, it's time for a little news you may have missed. So here on Fish Fry, we have talked quite a bit over the years about how we can better teach AI how to learn. A group of researchers at Imperial College London found that maybe the key to speeding up the education of AI might be found in the variability between our own brain cells. So, in this new study, it was revealed that by altering the electrical properties of individual brain cells in simulations of brain networks, those networks learned faster. So, why is this research important? This team from the Imperial College London says that it points to a possible reason why our brains are so good at learning. And that knowledge could very well help us build better artificially intelligent systems. Nicholas Perez, a PhD student at Imperial College London's Department of Electrical and Electronic Engineering, sums up their study like this. He says, "The brain needs to be energy efficient while still being able to excel at solving complex tasks. Our work suggests that having a diversity of neurons in both brains and AI systems fulfills these requirements and could boost learning." Okay, let's back up a little bit. So, we all know that our brains are made up of neurons, right? But no two neurons are exactly the same. From a distance, they may look similar, but on a closer inspection, no two neurons are exactly alike. So, each cell in an artificial neural network, on the other hand, are identical. And it's only their connectivity that varies from cell to cell. And it's this lack of cell variability that may be key to why neural networks don't learn as quickly or as accurately as our brains do. So this team from Imperial College London set out to study whether they could boost learning in AI by varying the neural network cell properties. And they found that yes, it works. Lead author Dr. Dan Goodman from Imperial's Department of Electrical and Electronic Engineering explains it like this. Evolution has given us incredible brain functions, most of which we are only beginning to understand. Our research suggests that we can learn vital lessons from our own biology to make AI work better for us. So, what kind of variation are we really talking about here? Well, this team actually concentrated specifically on varying the time constant within the cells, which determines how fast each cell determines what it wants to do based on what its connecting cells are doing. Now, some cells decide very quickly, looking at what other cells have done. Other cells, on the other hand, are slower to react, having based their decisions on what other cells have been doing for some time. So after this team varied the cells' time constants, they tasked their network to perform some benchmark machine learning tasks, including the recognition of human gestures, the identification of spoken commands and digits, and the classification of images of handwritten numbers and images of clothing. Now, what they found was pretty cool. They found that when they allowed the network to combine these two different kinds of learning methods, the slow and fast information gathering, that it was able to solve tasks in more complicated real-world settings. Very importantly, when they changed this amount of variability in their simulated networks, they found that the cells that performed best actually matched the amount of variability seen in the brain. So it seems that our brains may have evolved to have just the right amount of variability for optimal learning. Now, so it seems that our brains may have evolved to have just the right amount of variability for optimal learning. Nicholas Perez sums up their research like this. We demonstrated that AI could be brought closer to how our brains work by emulating certain brain properties. However, current AI systems are far from achieving the level of energy efficiency that we find in biological systems. Next, we will look at how to reduce the energy consumption of those networks to get AI networks closer to performing as efficiently as the brain. So, if you want even more information about this recent AI study coming out of the Imperial College London, I've included a couple links below the player on this week's Fish Fryin' page on eejournal.com. All right, it's time to bring in HanBin Lee, CEO of Seoul Robotics, to talk about the industry's first 3D perception software with deep learning. Let's go. Hi, HanBin. Thank you so much for joining me.
Thank you for having me.
Absolutely. Now, first off, for my audience who may not know, what is Seoul Robotics all about?
We are a 3D vision company. We provide the most advanced 3D perception software. Basically, sensors like LiDAR, imaging radar, and 3D camera provides information type called point cloud. And we process them with deep learning so that the client can understand what they're seeing through these type of 3D sensors.
Excellent. Now, you guys just introduced the industry's first 3D perception software with deep learning. So tell me more about this software and how is it different from other 3D computer vision software solutions on the market? I heard that it can sense more than 500 objects simultaneously with an accuracy range of 10 centimeters. Is that right?
So yeah, we actually developed the software back in 2017. Now, when you're trying to commercialize any deep learning technology, it can get quite tricky. So we actually rolled back our system to start making the product based on the rule-based system for the last couple of years. And then we were finally able to commercialize our initial deep learning technology to the mass market. And so the technology has been there, but this is the first time commercializing it. So there's a couple of misnomers here. It can actually track over 1,500 objects, let's say vehicles and people, et cetera, et cetera. But now we want to safely say it's 500 objects live, but technically the algorithm, the architecture can handle far more. Also, it can expand, depends on the type of computer you use. But the type of entry-level computer that we are selling to the customer together, we want to safely stick with 500 objects. And now this number 2, the accuracy 10 centimeter, that's what we tell publicly, but we just got the final report from Korean testing laboratory who has been testing our software extensively over a course of a couple of months. The result really came out to be around 4 centimeter accuracy. It's the power of deep learning, and it's really difficult to achieve this level of accuracy using a rule-based system.
That's fantastic. Now, Sensor 2.2 is sensor agnostic. So tell me about the compatibility aspect of this solution.
Yeah, so this really goes back to our beginning. Back in 2017, we saw numbers of LiDAR hardware companies arising, and we knew that the LiDAR price is going to be very competitive over time. And right now, there's a couple dozens of LiDAR hardware companies provider who were able to finally successfully commercialize their product. Now, when the customer wants to deploy a LiDAR-based solution, whether that be robotics, a smart city, or a self-driving car, they're faced with a lot of different hardware choices. But then when you choose a specific LiDAR, they still need to develop the software from the ground up. So we essentially said we need to make a platform. We need to make a perception platform that enables customers to choose whatever hardware, LiDAR or imaging radar of their dream, and able to utilize them right away without having to worry about creating this complex, often very resource extensive building of a perception system for LiDAR sensors. So we are compatible with almost all commercially available LiDAR, and any public LiDAR company now, there's about 8 or 9 of them at this point, are compatible with our software sensor, and they're actively co-marketing our product and selling it together with their hardware at this point. So that's the value proposition of Sensor 2.0. Being sensor agnostic, the customer can choose whichever LiDAR they want to use for whatever application they have.
Great. Now, you touched upon this a little bit, but let's talk about the development of sensor. So, tell me about the motivation to create this kind of software solution in the first place.
Right. So I do have to go back to 2017 once again. That's when the company was started. We are four 3D data engineer. Four of us, we met together online, studying through Udacity and Udemy, all these online courses available. Back then, that was like the first wave of MOOC. And at this Udacity, they hosted the self-driving competition where they're using radar, LiDAR, and camera to identify the object as accurate as possible. And our team, obviously, we came from the 3D data background, so said, let's just use LiDAR to see how far we can go. And out of 2,000 teams, we ended up in 10th using just LiDAR, and obviously the first using the LiDAR only approach. After that, we got a lot of love calls from the other self-driving companies asking us to join them to help making this LiDAR software for them. And I thought there's going to be so much demand just beyond, not just in the autonomous driving market, but beyond that, this kind of software will be needed for security, monitoring market, warehouse automation, et cetera, et cetera. So that's why we started building this product, again, based on deep learning in 2017. But it was hard to commercialize the deep learning product back then. So we rolled out the initial rule-based system in 2019. And then the goal was to help our customers to readily use, benefit from the 3D sensors like LiDAR, and help vehicles, robots, cities to understand what they see through the 3D sensors.
Fantastic. Now, Hanbin, I can definitely see how automotive applications would be a perfect fit for Sensor 2.2, but what other applications do you see being a good fit here?
Right. So the reason why we're focusing on the 3D perception, 3D vision, and LiDARs are we're trying to fill up the vacuum that the current existing sensor modality cannot provide. So I'm going to go very specific into each market. The smart city applications, often the LiDAR sensors, which I'm sure the listeners here are very familiar with, usually have a 360 kind of field of view. So it can cover the kind of intersections really well compared to existing solutions like radar, which has a narrower field of view, like best product out there has a 60 to 90 degree field of view, which can see down the road pretty far. But if you want to understand what's going on within the intersection, like pedestrian crossing, etc., the current sensor modalities, like such as camera, radar, tend to fail. Understanding where the pedestrians are exactly where they are is very important. So this is where 3D vision solution like ours is very complementary to the existing products and technologies out there. So that's one of those. The other applications are retails or just monitoring and security aspect of it. One of our clients, which is the largest retail store in Korea, is called eMart. It's a Korean version of Walmart. They adapted our technology after deploying a camera-based solution because, first of all, the location of the people are so accurate compared to existing products or technologies out there. Second of all, it did not contain any biometric information, no personal information, no facial gender information. The best information you can get out of this is like height of that person, also their tracking history. The system is currently being deployed in airports, museums, sports and music venues. And as far as the security system, it's being deployed for facilities with national importance who really needs to have a very accurate detection, intruder detection system. So basically, we're deploying this self-driving car perception technology for different industries such as smart cities and smart infrastructure overall.
Fantastic. Now let's switch gears a little bit here and talk about Voyage. Now, you guys introduced Voyage earlier this year, a plug and play LiDAR perception system. So tell my audience a bit about this all in one deployment kit and what all does it include?
Yeah. So first try to sell the software as it is. But we realized that installing this software for all this the millions of different computer variation was a pain. The customer has to go through reinstallation so many times until we realized that we just gotta sell it together with the computer all combined. And the selling a deep learning product initially was very difficult. So we have essentially bundled edge device computer pre-installed with our deep learning 3D vision solution. And also, if the customer wants to, we bundle them with the choice of their LiDAR we purchase for them. With all the wiring kits, et cetera, we put them in the one box. So the customer receives the solution to want to deploy 3D vision or LiDAR solutions for whatever application they want, they can essentially do it within, I've seen some people do it within like 10 minutes, but usually you can finish the installation of this kind of product within a day, deployment within a day, which is just not have heard of. It usually takes weeks and months to integrate and modify and optimize this type of technology, but we have reduced it to basically single day. So basically, it's providing the state-of-art, very accurate object understanding, such as detection, tracking, and classification. And additionally, we provide the volumetric profiling, the height of an object or volume of an object that can be utilized for a lot of like warehouse applications as well as the construction applications. Our product has been deployed in various applications, including those kind of a heavy industry as well. It is designed to be an, again, IoT edge device so that the output of the system is very light compared to if you're to receive and try to process the raw 3D data from the 3D sensors, you might need massive computation, but without doing that, you can just receive the information that you want to know.
Excellent. Well, this has been super cool. Thank you so much for joining me, HanBin.
All right. Thank you, Amelia.
And before we go, don't forget to check out my new maker-themed monthly fish fry podcast series called Makers Today. In our 5th episode of this series, I chat with Guido Bonelli from Dr. Duino. Guido and I chat about how art and electronic design intertwine in his life, how his Dr. Duino brand got started with a little help from Kickstarter, what his creation, the Goonie Box, is all about, and how the COVID-19 pandemic inspired him to create the social distancing Arduino project. And you can check out this episode by clicking the link below the player on this week's Fish Fryin' page on eejournal.com or by checking out the Fish Fry archive. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you want to follow my personal Twitter account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow me or us on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by, who would that be? Me. Yeah, that's right. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at amelia@eejournal.com or post a comment on our forums on EE Journal. For the week of October 29th, 2021, I'm Amelia Dalton. You've been fried.